All right, where did I put that? Good grief. I can't find anything in here. I don't know. Oh, crap. Okay, today I'm going to show you some more divisibility tests. I'll show you the test for divisibility by 4. I'll show you the test for divisibility by 8. And I'll show you the divisibility test by 7, which is a rare one. Your teacher may have told you there isn't such a thing. And I'll do this for giving us more practice on modular arithmetic. So I hope you find it interesting. Okay, another divisibility test that we learn about in school is divisibility by 4. And so I'm going to approach this again using modular arithmetic. First, set up things because we're going to make our decimal representation count for us. We have 10 modulo 4 is equal to 2. And then 2 times 2 is 4. So we have the 10 squared modulo 4 will be 2 times 2, which is 4, which is 0. And so since each of our factors, when we have 10 to the nth power, whenever n is greater than or equal to 2, each of these will have a factor of 10 squared in it. That modulo 4 will be equal to 0 because, you see, this is multiplicative. Okay, and looking here at our representation in decimals, when we reduce this mod 4, each of these terms which has a factor of 10 to a power in it will disappear when that power is greater than or equal to 2. So when we then all we need to look then now is a sub 1 times 10, a sub plus a sub 0, which is just the last 2 digits. And so this is how we get our divisibility test by 4. We just look at the last 2 digits. If that's divisible by 4, then the original number is divisible by 4. Otherwise, your original number will have the same remainder as whatever the last 2 digits of that number are. Okay, the test for divisibility by 8 is similar to the test for divisibility by 4. We can look 10 modulo 8 is 2. And so if we want 10 squared modulo 8, we look at 2 squared modulo 8. So that's 4 modulo 8, but that's 4. If we want 10 cubed modulo 8, that'll be 2 cubed modulo 8, which is 8 modulo 8, which is 0. And so whenever we have a 10 to the n, where n is greater than or equal to 3, that'll mean we'll have a 0. So when we take a general number expressed in decimal form and reduce it modulo 8, any powers of 10 for 3 powers of 3 and above will disappear. And so we only have to look at the last 3 digits. Okay, so my number 143,932, I only have to look at the last 3 digits of it. And, you know, if I want to deal with that, checking whether that last 3 digits is divisible by 8, I could just do that. But we do have a little bit more information here. I can say, okay, my 9 times 100, well, I can do 9 times 4 instead. And my 3 times 10, I can take 3 times 2 instead. And again, well, down to 2. Add these up. My 9 times 4, well, 9 modulo 8 is just 1, so that's 4. 3 times 2 is 6. And again, 2 is 2. Add these up, we get 12. Reduce that modulo 8, and it's 4. And so my original number, 143,932, divided by 8, leaves a remainder of 4. And so it's not evenly divisible by 8. All right, so when we're young and we're interested in arithmetic, we're introduced to these divisibility tests. Divisibility by 10, divisibility by 5, those are all quite simple. Divisibility by 2, you learn the song from Multiplication Rock about divisibility by 9. All that same thing works for 3. You can do your divisibility by 6, working out things. I've shown you the tricks for divisibility by 4, which, to be fair, a lot of teachers will show you. Divisibility by 8, you don't get quite a big payoff here. But when you ask for divisibility by 7, often the teacher will give you an answer similar to what your parents say when you ask where babies come from too early. They become evasive. Well, here I'm going to tell you the facts of life about divisibility by 7. Okay, so let's start off. Okay, again, we will be using our base 10 notation. Okay, 10 mod 7 is 3. Okay, 10 squared mod 7. Now I could do 100 divided by 7, but that's for chumps, because we can use the 3 whenever we use a 10 working mod 7. Okay, so what I mean, instead of 10 times 10, I would do 3 times 3 mod 7, which is 9 mod 7, which is 2. Okay, and so if I want 1,000, 10 to the 3rd mod 7, well, I can say that's the same as 10 times 100, that's 3, times 2, that's 6. Okay. 10 to the 4th mod 7, that's like 100 times 100 mod 7. That is 2 times 2, which is 4. 10 to the 5th mod 7. Oh, let's see, what's something easy to do here? If I do, I guess, 10 times 10 to the 4th, 3 times 4 is 12, mod 7 is 5. 10 to the 6th, so that would be like 10. What's the easiest way to do it here? Oh, goodness. If I do 10 squared times 10 to the 4th, that would be 2 times 4, that's 8, which mod 7 is equal to 1. And when I've got the 1 here, you'll notice what I'll be able to do is just cycle back through all of these. 10 to the 7th will be 2. 10 to the 8th will be 6. 10 to the 9th, 4, etc., etc., etc. And just cycle through 3, 2, 4, 1 again for all the powers. So I'm not lucky like I was with 9, where 10 mod 9 is 0. I'm not lucky like I was when I got to 4 or 8, where it's all eventually 0. I've got a cycle here. Now, let me take my number 1, 4, 7, 9, 3, 2, and see, this is times the 0th power times the 1st power times the 2nd power times the 3rd power times the 4th power times the 5th power. So this is 5, 4, 6, 2, 3, and we're just like 1 here. Okay. And so when I reduce this mod 7, it'll be 1 times 5 mod 7, which is 5. And I take 4 times 4 mod 7, that's 16 mod 7, that's 2. 7 times 6 mod 7, lucky, that's a 7, so this is just 0. 9 times 2, that's 18, mod 7, that's 4. Okay. 3 times 3 is 9, mod 7, that's equal to 2, and then finally just a 2 on the end. We're working mod 7. All right, so now, okay, I have a 5 and a 2, that's a 7. 7 mod 7 is 0. I have 4, 2, 2, that's 8. 8 mod 7 is 1. Okay. So what I know is this number, okay, 147,932 divided by 7 leaves a remainder of 1. Okay. If I were to add a 6 to this, right, make the last digit equal to 8, that number would be divisible by 7, because doing that would make this come out to be equal to 0 mod 7. So this is the divisibility trick. And you can see why it's not taught. It's not going to save you very much. It's just there's some, if you learn this sequence of numbers and you're dividing by 7 a lot, this might be worth your while. But quite frankly, I really can't be too hard on the teachers for being evasive. Though it might be a nice exercise for some of your more obnoxious students. Well, I hope you liked that. In subsequent videos, I'll be showing you why modular arithmetic works out. They'll be a little bit more theoretical. If you aren't a theoretical mindset, you might want to skip it. But I think it'll show you some more insight. In the meanwhile, if you like this, feel free to comment. Please like and share. Thank you very much. Bye-bye. Yeah, who is it? No, I'm not doing anything. Come on in.